Today we're going to be talking about nomenclature, which is, of course, the rules for naming compounds. The rules for naming compounds are established by an organization called IUPAC. IUPAC stands for the International Union of Physics and Applied Chemistry. Basically, there was no nomenclature rules before 1892, which might sound like it was a long time ago, but it really wasn't in chemistry. So prior to this, there were common names that were given to everything. And so these common names are still around, like acetic acid, which is really ethanoic acid. A lot of people still call it acetic acid, which is Latin for vinegar. Grain alcohol, a lot of people still call ethanol grain alcohol. This is an example of these older names, which are still widely used. Now, before we can learn NAIUPAC names, you must learn the names and structures of the 10 alkyl groups. So I already told you to memorize these. I told you meet Ethan, professional butler, but maybe you came up with something else. I saw someone had something about an octopus or something like that. So whatever works for you to memorize those. So an alkyl group, ALKYL, an alkyl group is the carbon that is attached into something, okay? So alkyl groups are classified according to the number of carbon atoms to which they are attached, okay? So we might think about this alkyl group as being bonded to something, this one is being bonded to something, this one is being bonded to something. We don't really care. But what we are looking at in this case is how many other carbons it's attached to. So this right here is a primary carbon because it's attached to one other carbons. This is a secondary carbon alkyl group because it's attached to two other, and this is tertiary because it's attached to three other carbons. Now that's not to say that there isn't something coming off of here or here as well. It's just to denote how many carbons those are attached to. So primary, secondary, and tertiary. To name the alkyl groups, it's really easy because you just take methane, remove the hydrogen, and you call it methyl. So its name is replaced with the ane, and you replace it with the YL or the ol. So methane becomes a methyl group, and again, it's attached to whatever here, R, or some long chain of carbons. Ethane becomes ethyl, propane becomes propyl, and so on. For these alkyl groups, for ethane, you can see here that all 6 of the hydrogens are equivalent. So you can remove any one of those hydrogens, and these all count as the same ethyl group. You can think about conformers and isomers like we were talking about. These are all exactly the same. When you start moving up past ethane to propyl, butyl, and pentyl, now you're going to have to look and see where things are attached. So again, we go back to this classification. A primary alkyl group has 1 carbon. This is secondary, and this is tertiary. These are what give us our names of primary and secondary groups, which are iso and sec. All right. Now, good news is you don't need to know these for my class. Bad news is there are still a lot of college professors that expect that you know them. So I will never test you on ISO. I will never test you on sec or tert, but I like to show you that they exist. So isopropyl has a classification of a secondary alkyl group because it has 1, 2 carbons attached off of it. Isobutyl, you can see here, is just a primary because it has only 1 carbon attached to the main carbon. And then here is sec-butyl. So you can see here the difference between isobutyl, sec-butyl, and then you can take it one further to tert-butyl. Now again, for me, you never need to know these common names. I will only be doing the IUPAC names, which I will teach you. But it doesn't hurt to know them if you're going to be moving on in chemistry. If we look at isobutane, all right, it can give 2 groups depending on whether it's a primary or a tertiary. So this is why this gets named this way. With the IUPAC nomenclature, we don't really have to worry about this, but actually learning the difference between a primary and a tertiary will help you in the alcohol naming chapter in the future. So here we go. This is what I teach you in this class. This is what you need to know is IUPAC nomenclature. And we're going to start with just the alkanes. Remember, alkanes are just carbons attached to a whole lot of hydrogens. You need to make sure as you're drawing these and thinking about these that your carbon is bonding 4 times and 4 times only. Every carbon bonds 4 times and 4 times only. So rule number 1, the base or the parent name for the alkane is determined by the longest chain of carbon atoms in the formula. So in this case of the one I just drew, 1, 2, 3 is my longest chain. So I know that 3 is propane. So this is going to be propane. But you need to watch out because the longest chain might bend, it might twist. It is actually very seldom horizontal, and I'll show you a lot of examples of this. Any carbon groups that are not part of the base chain or the parent chain are called branches or substituents. I use both of these terms interchangeably. These carbon groups are also called alkyl groups, and I'll show you where the alkyl groups fit in. So here's rule number 1 applied. Find the longest chain in each molecule. Now remember, your eyes might be drawn to here, but it is seldom just horizontal. Sometimes it bends and turns and twists. So I'd like to count 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8. So that's actually going to be my longest chain in this case. So see how it bends and twists there? I don't care because remember the sigma bonds in the carbon to carbon bond twist. Now looking at this one, 1, 2, 3, 4, 5, 6, 7, that is the longest chain there. So what I like to do at first is circle the parent chain. My next step is going to be to circle the substituents. I've got just a methyl group there, and off of this one I have a methyl and an ethyl. The next rule is going to be to number these, okay? So this is the 8 carbon chain or the octane, and this one is the 7 carbon chain or the heptane. Well, the next rule we're going to learn about is numbering them, and you actually are going to number these in this direction. The reason that you number them in this direction is because you're looking for it to branch first. So if you were to number it in the other direction, it wouldn't branch as early. So this is rule number 2. Number the carbon atoms in the chain starting from the end with the first branch. So these are the ones that we just were looking at. Here's my octane. And here is my heptane. Again, at the 3rd carbon is a methyl group. At this 3rd carbon is a methyl group. And at the 5th carbon is an ethyl group. So I have a methyl and an ethyl, and for this one I just have a methyl. If both branches are equally from the ends, continue until a point of a difference occurs, and I'll give you some examples of that. The third rule is to write each of the branches or substituents in alphabetical order before the base or the stem name. Alphabetical order might sound a little bit funny at first, but you will get used to it. Halogens usually come first. You're going to indicate the position of the branch by prefixing its name with the carbon number to which it's attached. I'll show you examples of that. Separate letters and numbers with a hyphen, and 2 or more numbers with commas. And yes, I'll be a stickler of this. If you forget a hyphen or put a hyphen or a comma where it's supposed to not be, we're going to have to change it. So let's take a look at this. First of all, step number 1, I need to find the longest carbon chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It really doesn't matter which of those I circle because they're all actually going to be the same. So I'm just going to circle this one. Then I like to circle my substituents. There's a methyl group. Here's the ethyl group. Then I go ahead and number them. Carbon number 1, 2, 3, 4, 5, 6. Now, the reason that I started in this direction was because I wanted this branch to come first. If I would have numbered 1, 2, 3, then I wouldn't have branched until the third carbon. So I can go ahead and give this a name. This has an ethyl, which begins with E, and a methyl, which begins with M. So as I write the name, I write 4-ethyl dash 2. I almost forgot my dash there. Methyl, and this entire thing is a hexane. A hexane, and you'll notice there's no dash, there's no comma in there, it's just all one word. So again, this is my 4-ethyl, this is my 2-methyl, and this entire thing is a hexane. 4-ethyl, 2-methyl hexane. Now, sometimes it gets a little bit more complicated when a branch or substituent occurs more than once. You need to give the prefixes the names with di, tri, or tetra. Again, di is 2, right? Di means there are 2 of them, tri means there are 3 of them, and tetra, like the game Tetris, is 4. Then you're going to list the carbons, and you're going to separate those branches with commas. So, for example, you may have a 3,4-dimethyl. That means that there are 2 methyl groups coming off of carbon 3 and carbon number 4. Or maybe you have a 4,4,6 triethyl. This would have to be a mighty big molecule for this to happen. So let's take a look at this and go through our naming. First of all, find the longest branch. 1, 2, 3, 4, 5, 6, 7. I can double check here. 1, 2, 3, 4, 5, 6, 7. That's exactly the same. Just to prove to you that twisting works just fine, I'm going to show you the twisted up version of this because it will come out exactly the same as the straight chain as long as you followed all the rules. So there's my longest chain. I'm going to circle my substituents. There's a methyl, and there is an ethyl. Now I'd like to number them. Starting over here would be carbon 1, 2, and the branch would happen at 3. Starting over here would be carbon 1, 2, so the branch would happen off of 2. So that's why I want to go carbon 1, 2, 3, 4, 5, 6, carbon number 7. Then I'm going to go ahead and I'm going to start in alphabetical order. Now you might think that dimethyl comes before ethyl, but you ignore the di in dimethyl. You still think that the ethyl comes before the methyl, which is a little bit confusing. So this is actually named 5-ethyl. And then I have a methyl on 2, 3, dimethyl. And then this entire thing is called, again, a hexane for 6. So here's my ethyl off of number 5. I have 2 methyls. That's why there's a dimethyl off of carbon 2 and carbon 3. And then this entire chain is, oh, it's 7 long. Look at that. I messed it up. It's not a hexane. It's a heptane. It is a heptane. There are 7. So I'm sorry that I got that one wrong. So 5-ethyl, 2,3-dimethyl heptane. Even though the ethyl comes before the dimethyl in the alphabet, you would think it was reverse. We still want the E to come before the M when we're naming it like this. Here's another example. They're already kind of circled for you so you can see. Here's my parent chain. I've got a couple of methyls. I've got an ethyl. The direction that I'm going to number this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm working on a decane here because there are 10 carbons. So I'm going to end up with a 6-ethyl and a 3,3-dimethyl, and again, this is a decane. Another naming, I said that you needed to learn the alcohols. You need to know what an alcohol was. And I also wanted you to know what an alkyl halide was. Okay. So alkyl halides, the halogens are group 17 from the periodic table. And the alkyl halides are alkanes bearing these halogens as substituents. So they're named just like they were in Chem 1. We've got fluoro, bromo, chloro, and the I for iodo. So this right here is called chloromethane. Chloromethane. Now notice it's not one chloromethane because there's only one spot for it. So it has to be one. Chemists hate redundancy. This is fluoroethane. Again, you don't need to put a 1 because whether the fluorine was here or here, it would be at position 1. Looking down here, when we get to the 1, 2, 3, or the propane, now we've got to put a number on it. So in this case, this is 2-iodopropane. Here is an interesting one, 1, 2, 3, 4. So we're at a butane, but when you number this, you need to make sure to number it in this direction because you want the bromo to branch off earliest. One of the most common mistakes I see people making is that they forget that they're reading no longer from left to right and it can go in any direction. So this becomes a 2-bromobutane. And then this one, I like this because they actually meant this as the parent chain. So my parent chain has 1, 2, 3, or again, a propane with 3 carbons, and I have a methyl substituent, and I have a bromo substituent. So this becomes a 2-bromo, because bromo comes before methyl in the alphabet, 2-methyl propane, and notice that I have those hyphens there. So let's go ahead and practice now going the other direction. If I were to give you 1-bromo 4-methylhexane, you need to run this entire thing backwards. At first, you need to look at the fact that it's a hexane or it has 6 carbons. And then from there, you need to draw your substituents, whatever they may be. So you begin by drawing the carbon chain, the 6-carbon parent chain, and show all 4 bonds coming off of each carbon. Your second step is to add the substituents. So off of carbon number 1, 2, 3, 4, 5, 6, you can see I have placed my bromo, and off of carbon number 4, I have placed my methyl group or my CH3. And then from there, as you probably guessed was going to happen, I'm going to add in all the rest of the H's. Wherever there was a substituent, you don't need to have them. And then from there, you can condense that chemical formula if the question asks you to. So not really sure why this bromine is listed there. It could have just as easily been listed over here and written like that, but it is. Also, same thing, if we're showing a branch, we could put this CH2 into parentheses, but that's just, other ways of showing things.